Are you recording this too? Are you recording this as well?
Yo,
Wait, can you hear me? Can you hear me?
can you hear me?
I can hear you.
I can't hear you, man.
Huh, really? Wait, are you recording this as well?
Hello,
Hello?
hello, hello.
Hello?
It's very soft. You need to use a. You need to use your earpiece or something.
I'm speaking into the mic.
But it's really very soft.
Wait, hold up.
Yes. Oh my god, so much better now.
Huh? I didn't even do anything.
I think maybe it's the internet connection.
Yeah, my Wi-Fi is down. I don't know what's wrong.
Yeah, so much better now.
Okay.
Okay. And welcome back to another episode of Math with Kenny. Can you see the banner up there?
Oh my gosh. Very nice.
Not bad, right? Oh yeah, I haven't uploaded our video actually. I'll upload soon. I don't know why recently my business quite good.
Oh, really?
In the sense that I keep getting math questions to solve. Not that I have more students.
Oh, sorry. Okay, no, this one is just
No, it's not. Sorry, I seen like I don't know why recently suddenly a lot, like which is very good. Like usually I don't even have any. Huh?
Now
What?
we are freer.
Oh yeah, maybe now. Yeah, agree. Okay. Let's come to this. Okay, I'm going to do something here. I want to blank out this thing. Because of this advanced level, it makes people like feel like this thing is difficult. Okay, anyway, the proportion of the defective articles is P. Okay, which in other words, right, it also means that, right, the probability of it being a defective article, right, is P over 100. Okay?
Oh, it's P over 100?
Yes.
Oh, it's just P.
Because it's a proportion.
Mm,
This is how it's being defined.
right.
Okay, it's like a percentage. From each batch, a random sample of 9, okay, is taken, and each of these 9 articles is examined. Okay, so we know that N is N is 9, and probability of success, which is P over 100, and the success means for it to be defective. If 2 or more of the 9 articles are found to be defective, the batch is rejected, otherwise accepted. Proof that for it to be accepted is this. Okay. So we know that X will be, define X is the number of effective articles in a sample of 9. Okay, so X follows binomial distribution 9, P over 100. Okay, so we know that 2 or more rejected means lesser than 2. The probability of accepted will be equals to probability of X less than 2. which is equals to probability of x less or equals to 1. Make sense? Yeah. So probability of x less or equals to 1 will be probability of x equals to 0 and plus probability of x equals 1. Can? Hello? Can you hear me?
Hello?
Yes, and welcome back to another
Sorry.
episode of Math with Kenny.
Sorry. My bad.
Okay, so I don't know where were you are. I was going through this thing with myself.
Oh, sorry.
Okay, so probability of being accepted is equals to px lesser than 2. Did we stop here?
Yes.
Yeah. Then px lesser than 2 means px lesser or equals to 1. Right?
Yeah.
Px lesser equals to 1 means we have to use px equals 0 plus px equals 1. There's a problem here because we don't have we cannot find this because we are supposed to express in terms of p. Correct?
Yeah.
Yeah. So since we are supposed to express in terms of p, that's why we need to go and use the probability formula, which is over here. Okay. This is the formula that you have in your book.
Sorry. The px less than 2 is because
Because they said that 2 or more will be rejected. We want to find accepted, so must be less than 2.
Oh, and cannot be inclusive, right?
Yeah. Because they say 2 or more is rejected one. So 2 will be rejected also. So it need to be lesser than 2.
Okay.
Yeah. So this is the formula. Whether you can, this formula should be given in your MF26.
Oh, yes.
Right?
Yeah.
Can you help me check if this is the correct formula?
Yes.
Correct.
No. It's 1 minus. No. It's n choose x, p to the power of x. And 1 minus
Actually,
p.
I think no difference. N
1
minus
minus
x.
n minus x. Yeah. Oh, no diff.
I think no difference. Can you calculate for me? Like for instance, 9 choose 2. Let's say p is 0.6 to the power of 2 and 0.4 to the power of what is this? 7. And then also 9 choose 2, 0.6 to the power 9 choose 9 choose 0.2 to the power. There should be difference, oh. There should be a difference, right?
Yeah.
Because we are choosing the number of
Yeah, there's a
probability of
difference.
success. Yeah, correct. Sorry. Yeah, there should be a difference. There should be a difference. Okay, so over here will be p to the power of 0, 1 minus p to the power of 9 minus 0, which is 9. So 9 choose 0 is what? 1, right? P to the power of 0 is what? 1. So we're left with 1 minus p to the power of 9. Right?
Yeah.
Then next will be probability of x equals to 1. So it will be 9 choose 1, p to the power of 1, 1 minus p to the power of 8. Right?
Yeah.
Yeah, which is equals to 9 choose 1 is 9p, 1 minus p to the power of 8. So over here, what we will get is 1 minus p to the power of 9 plus 9p, 1 minus p to the power of 8. So we have to take out, factorize out 1 minus p plus, so we are left with, oops, sorry, 1 minus p to the power of, sorry, I take out 1 to the power 8. Oh, not thinking straight. Plus
Why?
9p.
What? You had many lessons today?
Today I had like 3 lessons and 1 consult.
Oh my.
I'm quite although it's like only 6-7 hours, but actually quite draining, man. Because I think tutoring, right, and a normal job is different. Because a normal job, right, is like you don't need to be like 100% on the ball. But when you're in class, right, you really have to be like, you have to understand whether the person understands what you're saying or not. You're constantly talking, right?
Yeah.
Yeah, but let's say a normal job, right? It's like you can still chill, go to a pantry, relax.
Yeah.
Yeah, that kind of.
It's okay. One question only, and I am kind
No,
of.
no, 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 no. I'm fine. If not, I won't zoom you already. Yeah, because at math with Kenny, right, we believe in putting students before myself. So please,
That's true, everyone.
yes, please quote net CJC for 1 free trial lesson. Okay, so we have 1 plus 8p here, and therefore shown. Okay.
Yeah.
Can I? Okay, I'm gonna clear it. Okay. Hello.
Okay.
Okay.
Mm.
Okay. Then following up is it is decided to modify the sampling scheme so that when one defective is found, okay, a second sample of 9 is taken. Okay, so basically the first batch, they found 1 defective, they will straight away take a second sample of 9. and the batch is rejected if this contains any defective. What does this mean? When one defective is found, a second sample of 9 is taken.
Also out of the 7 that is defective, you like take a second sample. What is the batch rejected if this contains any defectives?
Sorry, hold on. Wait. Okay. It's decided to modify the sampling scheme so that when one defective is found in the sample, a second sample of 9 is taken, and the batch rejected if. What does it mean by one defective is found in the sample, a second sample of 9 is taken? Oh, I know already. You see, if you read carefully right at the top, right? In each batch, okay, so it's one whole batch of manufactured articles, okay? And each batch, right, they will take a sample of 9. Means in this batch, right, there are a lot. There are a lot of, let's say, iPhones. There are a lot of iPhones. So in this whole sea of iPhones, right, I'm going to take 9 as a sample. Okay, I'm going to anyhow randomly I take 9. Okay, can? Hello? Yeah, I'll take 9. So if any one of these 9, right, any one of these 9 is found to be defective, which is what is stating over here. If any one of these 9 is said to be defective, then I will take another 9 more iPhones to test. Okay, so after I take another 9 phones to test, okay, if I found any defective again, this whole batch, right, the maybe 1,000 iPhones, right, they will be rejected already.
Okay.
Understand?
Yeah.
Yeah. So with this exception, the original scheme is continued. With this exception, the original scheme is continued. What does it mean by original scheme is continued? With this exception, do you understand?
I
With
think the
this
original.
exception, what do you mean with this exception?
I think the original is like the top paragraph.
Yeah. Of course.
So then,
What does I don't understand why he said that with this exception, 2 or more of the 9 articles are found to be defective. Then the batch is. That is very crucial, and we don't even understand that statement. With this exception, the original scheme is continued. Means what? With this exception, the original scheme is continued. Find an expression in terms of P for the probability that a batch is accepted. Oh, I get what I mean already. Two or more of the 9 articles are found to be defective. Oh, okay, I know already. I understand what it means already. Okay, look here.
Sorry.
So I understand what it means already.
Okay.
Wow, not bad, right? My drawing. Okay, look here. Okay, there's like a lot of iPhones. Okay, there are a lot of iPhones. So in the first sample, there are 9 iPhones. Okay. Hello.
Mm-hmm.
Yeah. In the first sample, there are 9 iPhones. So if I found for the first sample, right? If I were to find 0 defective, okay, the result will be accepted already. Okay, if I find 1 defective, okay, straight away I will go to the second sample. Okay, then from the second sample, if I found just one defective, it will be rejected. Okay.
Oh, okay. Yeah.
Okay. If I found 2 defective from the first sample, straight away is rejected. This is what it means by, with this exception, the original scheme is continued, because in the first paragraph here, right, if 2 or more, you see, if 2 or more of the 9 articles are found to be defective, the batch is rejected, which is talking about this part.
Yeah.
Yeah. So we got 0 defective, 1 defective, and 2 defective. So we want to find the probability such that the batch is accepted. For the batch to be accepted, right, there are only 2 ways for it to be accepted here. First way is that the first batch totally 0 defective. Okay?
Yeah.
Okay, we need to find that first batch 0 defective.
Oh, I get it now.
Yeah. The second way is that I find 1 defective in sample 1 and 0 defective in sample 2, then it can allow me to be accepted. Understand?
Yeah.
Yeah. So in other words, the probability of the first sample to be equals to 0 will be equals to 9 choose 0, p to the power of 0, 1 minus p to the power of 9, which is equivalent to 1 minus p to the power of 9. This is the probability that it will be accepted for the first case when you straight away find 0 defective. Okay. Or there will be probability of x equals to 1. Okay. Which is 9 choose 1. You're listening, right?
Yeah.
Yeah. Just want to make sure.
I
9 choose
copy.
1, p to the power of 1, 1 minus p to the power of 8. Okay. Which will give you 9p, 1 minus p to the power of 8. This for sample 1. Okay. So you have to make sure that the sample 2 is 0. So when we take the second sample, we need to find probability of okay, maybe we put this as x1. then it's x1. Then we have a x2, which is the second sample. We want the second sample to be equals to 0, which is equals to 1 minus p to the power of 9, like what we have calculated here. Right? So this thing, this probability here and this probability here have to multiply together because they are dependent on each other. It's an n. Okay, you understand what I'm trying to say?
Yeah.
Yeah. So the expression in terms of p would have to be this one plus the multiplication of this one.
Okay.
Okay?
Yeah.
Yeah. Then lastly, for the modified scheme, evaluate the average number sampled. So the average number sampled over a large, when p has, so now you have the value of p already. P is 0.1. So now you have p. P is 0.1.
Oh, I got the answer already.
Oh, really?
Yeah.
How?
Wait, after that, just factorize what?
What do you mean?
Oh, wait, are you talking about the second part?
I'm talking about second part.
Oh, okay, my bad, my bad.
Do you listen to the second part? Or not?
No, I wasn't there yet. Wait, can you say again the last sentence?
No, no, as in like this part. Like this part. This part.
Oh, yeah. I did.
Yeah. I haven't solved the last part yet.
Oh, yeah. As in that. Oh my
As
god. As
in
in that part I did already.
this part and this part you were listening, right?
Oh, yeah. As in I got the answer for that.
Okay, this part is still a question mark.
Yeah.
I don't know what I'm trying to say. The average number sampled. How to find the average number sampled? The average number sampled. Which means you're trying to find the expectation of the number sampled. Wow. So right, let me erase this. Wow, this is damn crazy, you know. It's really advanced.
So if my teacher sees that I know how to do, he'll probably find it damn odd.
Why? Doesn't matter, as long as you understand, right? Because if
That's
not,
true.
right, later you don't know how to do, then after that you also don't understand. Then what's the point? Right?
Yeah, that's true.
Yeah. So now, okay, for this last part, right, they want to calculate the average number sampled. Now, okay, it's the average number of iPhones sampled, for instance. So, which also, okay, you see, this whole question is basically right. Wanting you to understand the math from the English that they use. If you're able to translate their English into math or translate their English into the scenario that they want to paint, right, you will have gotten an answer. Okay, so here they're talking about average number sampled, which is expectation of the number sampled, number of articles.
Oh wait, but I thought it's for the modified scheme, so it's sample 2.
Modified scheme means it's just a scheme, is that which is everything that I mentioned just now. You get 0 defective, straight away accepted. You get 1 defective, you have to go to sample 2 to see whether if you got 1 defective, then rejected. If you got 0 defective, then accepted.
Oh, okay.
That's the scheme we are talking about. Okay, so in part 3 over here, right, they ask you to calculate, evaluate the average number sampled. So if you want to translate it into mathematical sense, right, it'll be the expectation of the number of articles sampled. So which means now, right, which means now I have to come up with a new variable, which is y. Because I want to find expectation. Expectation is what? It's equivalent to the the value of the random variable multiplied by the corresponding probability, then you add them up together, right?
Yeah.
So now we have to define a new random variable y, which is the number of articles sampled. Okay, so we have to draw the table.
Are you serious?
Yeah lor, I wanted to question that also. This question damn siao. So the number sampled per manufactured batch, right? Over a large number of, okay, whatever lah. Okay. So over here will be y, probability of big Y equals to small y. So it's either 9 samples or 18 samples, right? Makes sense. Because no matter what die, I also need to sample 9 articles.
Yeah.
Right? That's the minimum. The maximum I can go is 18 because I take sample 2. Correct?
Yeah.
Yeah. So the probability of just sampling 1 article is what?
1 out of 9.
Huh? No. The probability of sampling 9 articles, as in like, we just need, means we, according to our scheme just now, right? You still remember our scheme?
Yeah.
Yeah. You copy that down, right?
Yeah.
Okay. If you forget, right, later I will send you the video, we can review it. Okay. Oh, I removed my banner.
Okay.
Damn strong. Okay, so what's the probability of just sampling 9 articles, which is 0 defective, right? 0 defective is the only way where I can sample one article, right? Sorry, I can sample 9 articles, which is over here. This is the probability of sampling only 9 articles, which is sample 1 itself. Do you agree?
Yeah.
Yeah, so they give you the value of P already. So can you calculate the value of P, which is equals to 0.9 to the power of 9. 0.9 to the power of, 9. Right? Make
Wait,
sense?
is it not 1 minus 0.1?
Yeah lor, which is
Power
0.9 lah. Which is 0.9, right?
Oh, yes. Oh, I went to calculate it out. Okay, never mind.
Yeah.
My bad. Okay.
Then for this one, right? For 18, right? It will just be 1 minus 0.9 to the power of 9. Make sense?
Yeah.
Yeah, because the summation of the probability should be equals to 1. Then from here, you can find the expected number of articles sampled already. How? Multiply, plus.
Okay.
You get 14.513, is it? I hope that's the answer.
I got 14.5, but then the answer is 12.5.
GG. Is something wrong? It can be 9 articles. If sample 2 is 0 articles, evaluate the average number sampled per manufactured batch over a large. What did he say? Over a large number of batches. Answer is what?
12.5. Is it not 9?
What do you mean?
Like it's not 9 articles sample.
You see the average number sampled. What? This number means number of articles, right? And if this is a probability distribution function, this whole part here should be equals to 1. Why though? What is 1 minus 0.1?
0.9.
Correct, right? It's 0.9, right?
Yeah.
Wow, what is wrong? For part 1 and part 2 is correct, is it?
Yeah.
Average number sampled per manufactured batch. Means they want me to find the mean, which is the expectation. So that's why you have to come out with DRV. The intention is correct. Two or more, if it's two, oh, I'm sorry, I forgot to add this in. Sorry, my bad.
Add what?
Because right, to test for the first sample, right? Okay. Sorry, to test for the first sample, right? Can I erase this one? You
Yeah,
understood this part already, right?
Yeah.
Okay. So I still want to keep the rest of stuff.
Yeah, sure.
Okay. To only test sample 1, remember just now I said 0 defects.
Yeah.
1 defect.
Yeah.
And 2 defect. If
Yeah.
it's 0 defects, yes, it will be this probability. Okay. If it's 1 defect, it will go to sample 2, right? Make
Yeah.
sense? Yeah, which is this probability over here, right?
Yeah.
If it's 2 defects, straight away it's rejected also, correct?
Yeah.
Which means it should add to this probability also.
So the 2
So
defects should be.
yes. So what's the probability of finding 2 defects? So we need to
Ah,
find
so we add another one, is it? Like another
yeah,
column.
yeah, correct. No. We have to for the probability here, right? Here, right? Can you see?
Mm-hmm.
For the probability here is actually px equals 2 plus px equals 0.
Mm-hmm.
Yeah.
So 2 times of it, is it?
As in px, no. You have to find px, sorry, my bad. You have to find px greater or equals to 0. Not that. Px greater or equals to 0. Equals to 2, sorry, not 0. Because you have 2 or more defects, right? Straight away, sample 1 will be rejected, which means you only test 9 articles only. Make sense to you?
Yeah.
Yeah. So you already know that px equals to 0 is 0.9 to the power 9, right?
Yeah.
So you have to find what is px greater or equals to 2 here. So how to find px greater or equals to 2? We already found, right? In part 1.
Yeah.
That's why I was thinking the sentence intention like doesn't seem right. Because we haven't used part 1 and part 2 to solve. Part 1 we found, what is this? What is it that we find in part 1? Px lesser or equals to 1, right?
Yeah.
Yeah. So px greater or equals to 2 is 1 minus px lesser or equals to 1.
Wait, that means we have to find it separately, is it?
What do you mean?
Like, cause we have px equals to 0, then there's one probability. Then px more than equals to 2 is another probability, but it's the same.
No, you have to find separately, of course. It's not the same. They don't share the same probability.
Oh, then how come the 2 defects one have the probability is 0.9 to the power 9? Or is it wrong?
No, I never say that. I say that, what I'm trying to say that 0 defects and 2 defects will contribute to the probability here. This should not be present already. This is the wrong answer.
Oh.
Yeah, I'm saying that over here, you have to find your px equals 0 plus px lesser or equals to 2.
Okay.
Can you find it for me? Then for the other side, you can just 1 minus that.
Okay.
Chop.
It's 1. The answer is 1.
Answer is 1.
Because 1 minus p x less than 1 equals
What is the probability of px lesser or equals to 1? You have to substitute the
I
p
count
as
again.
0.1.
Yeah, I did. Yeah, I count again. Um, 0.225.
Yeah, you just tabulate first, then after you see.
0.613. The probability is 0.613.
Okay. Then after that, you will know the probability for the
0.387.
yeah.
I think it's correct already.
How you know?
The number seems right.
You have to get to the end goal first.
Oh my god. It's 12.5.
Is it answer?
Yeah.
What can I say? Mic
Everyone,
drop.
give this video a like.
Yes. Yes. Like, share, subscribe.
What kind of question is this? This is so
This is
stupid.
very crazy. This is a very crazy question.
That's so stupid. What the heck?
Yeah, but I tell you, tomorrow you're going to present on Zoom.
Yeah, because my teacher will have a Google Meet, right?
Have what?
Yeah, something like Zoom,
Oh, no, you're using what? Google what?
Google Meet.
It's something like Zoom also.
Yeah, kinda.
Oh, so cool. It's
Cause
free. It's free.
that was Google, what? But then like, cause like apparently schools cannot really use Zoom
Yeah, how to spell that? Google what?
Meet.
MEET.
Yeah.
Okay. My God, I can't believe we solved it. I mean, like, I'm glad that my years of uh statistical work in uni paid off.
Yeah, dude, this question is insane. Oh my gosh, I used like almost one A4 paper.
I swear, right? Tomorrow the teacher will be so impressed because this question is
I'm so
different.
impressed.
Because this question is an abnormal question. This will not be an A-levels question. As you can see, this is like a what? November 21, November 81. That was like so long back then. The syllabus have changed now. Now the way they test it's not structured like that. This is a very weird way of like testing a student's mathematical concept. It's more like testing English or
Yeah.
yeah.
Hello?
Okay, yeah,
Oh,
yeah.
okay.
So you know, right? I hope you have a successful presentation.
Okay, now I mean technically my teacher will be presenting it for me, I guess.
What? Sorry again.
Oh, nothing. Thanks.
Your teacher will be presenting it for you.
Yeah.
For what? You tell
As
the
in I
teacher
send it to him, then he'll go through line by line. Then I have to answer his question, something like that.
you stop him. You just stop him. You say that, hey yo dude, I got this man. I got this. You should do that tomorrow. Yeah. Serious.
Okay.
Yeah. Honestly speaking, right, it's very easy for them to present on. Why leh? Because they have the solution set. They have the answer booklet. You get what I mean?
Mm-hmm.
Yeah. You ask him to do it raw, like without the solution booklet. You're gonna explain line by line, right?
Yeah.
He will show the working, right? Will he show the working?
Yeah. My teacher is very, very dedicated though.
I know. But right, I know dedication. There's a difference between working hard and working smart. A lot of teachers, they are like hard workers, but you see, the whole point of transferring the knowledge is about replicating mindset, replicating perspective. But when you put the solution set there, right, it's like, you are not helping the person to think. When I break down the question like that, the student will be like, oh, this is how I should look at the question, and not, oh, this is how the solution presents itself. You know what I'm trying to say?
Yeah.
Yeah. So it's very important, like how you, like, even when if your friend were to ask you, hey, Nat, how to do this question, so when you teach them, you cannot teach them using the solution. You must teach them that, okay, this is the question, so this is what the question say, therefore this. So from this we can infer that this. Yeah. Understandable.
Yeah.
Okay, so code Nat CJC for one future lesson. And remember to like, share, and subscribe.
Oh
Thank you
no, they
for.
could hear everything you're saying about my teacher.
Doesn't matter lah. They won't know who is that teacher. There's more than one Natalie in CJC, right?
Yeah.
Yeah. Then it's fine. Okay, you know what? I'm dead beat.
Yeah, it's okay.
What is okay?
As in, don't worry, just go.
Okay, I'm going to pass away.
Okay. Okay, then I'll ask you tomorrow.
I still got another question.
No.
Oh,
Never mind, I'll tell you
tomorrow
tomorrow.
during our lesson, then we clarify.
Yeah.
All right.
Good night.
No, that wasn't what I was going to write.
I say good night.
No, I'm not writing good night.
You got nothing else to write? Okay, good morning.
Yeah. No lah. I wanted to write good night. I just don't want to be figured out.
Huh?
Nothing. Okay, man. You should sleep soon. Why are you still awake?
Like I have a choice.
Huh? What do you mean? After this can sleep already ah.
I got econs.
Econs lesson.
Homework.
Econs homework. Don't need to do one ah.
See my mood lah.
Huh?
See my mood.
No, you have to present tomorrow also.
No. Just prep work.
Wow, you very hardworking you.
No.
Last time for me, right, I will do the homework right after the submission. Then power, right? Hello?
Yeah.
Yeah. Okay, gotta go.
Okay.
Okay, bye.
Bye. Thank you.